Okay, so the next thing for functions operation. This is something they do ask quite a bit on the Regents. It's not too bad once you understand the symbols. It's just algebra. Number one, g of n is 2n plus 5, f of n, negative 3n squared plus 3. Now it says find g of n times f of n. So you just multiply those. That dot means multiply, g times f. Well, we just said that's g. You've got to use parentheses because it's a binomial. There's f of that. Just do the distribution. 2 times negative 3, negative 6. N times n squared, n cubed, plus 6n, minus 15n squared, plus 15. Now, there are no like terms there. Really, the only thing you could do is maybe put the n squared next. And there's that. Now, 2, same idea. This time it says g plus h. So, there's g, there's h. I didn't need parentheses there. There's nothing to distribute or anything. Also, there's no like terms here. Nothing to add or subtract. Negative n squared. That 4n is positive, so plus 4n minus 2. Number 3, and there's a little bit of a typo here. This should be t squared. So just so you're aware of that, that should be t squared. Now this one's pretty similar, but we got extra numbers. So 5g, 5 times g, it's a binomial, so I got to put parentheses around it, plus 2f. And remember that f should have had t squared. Now we have something to do. We'll distribute. And then over here, there's nothing to distribute. It's a monomial. So it's just 2 times 3. I can put the t squareds together. Negative 15 plus 6 is negative 9. Number 4, same idea. F minus g. So F, it says, is x cubed plus x squared plus 2x minus g. Well, minus, but g has a minus. So a minus and negative switches that to plus. Combine the like terms. Well, they're just the 2 x's at the end. 2x plus another x is 3x. Number 5, g times h. So there's no numbers this time, no distribution of numbers. We can just jump straight to the distribution for the question. Three x to the 4th minus 3x squared plus 5x cubed minus 5x. Now hopefully this is making sense to you. All we really got to do is just follow what it says. Find 5g. Well, that's 5 times g. Plus 3 times h. H is n squared minus 3n. Those were both polynomials. They're both binomials, so I had to use those parentheses. Now I'll distribute. Well, the 3n squared's got to come first. There's nothing I can do with it, but I'll just move it out to the front. I can combine 10n minus 9n. That's 1n. And then nothing to do with 5. Just bring it down. Okay. Even and odd functions. The last topic for the unit. Function is an even function if, remember what this means. X is the input. So f of x, the function value, the output for even functions is the same, whether you put a positive number in or a negative number. And the way you test this on the graph is symmetric with respect to the y-axis, meaning you can fold it over the y. If it's a mirror image, if it folds onto itself, it's even. A function is odd. This one's a little different. Now, let me rephrase this. So instead of being the same, if I put a negative in, you get the opposite out. Say a function, like 2 times x. If I put 3 in, 2 times 3 is 6. If I put negative 3 in, that's negative 6. So you get the opposite. And this graphic check is the origin. Now, flip is the wrong word. Whoever made this, that shouldn't be there. It's rotate upside down. Literally rotate your paper upside down. And we'll see if I can get that to work. Let's take a look. All right. So determine graphically, even, odd, or neither. Okay, the test for even is a mirror image across the y-axis. Now, if you notice on choice 1, I fold that over. That's not lining up with itself down there. So that's definitely not even. Now, the odd test, let's see if I can just do this on a little sketch here. So pay attention to the way this looks. It's starting from the bottom left, going to the upper right. If I literally rotate this over, might work better with a mouse here. Now we want to see if this will be exactly the same if I rotate it over. So we're starting bottom left and going up. Well, we're starting bottom left and going up still, but look, here it's crossing the y-axis in the negatives beneath the x. But when I rotate it, Now it's above the x. That's one thing I don't like about this worksheet that I found. Everything else is good. The first one is neither. Two's easier though. You fold that right over itself, it lines up, so that's even. 3, even. It's like a mirror image across the y-axis. Now 4. Well, 4, I don't know, let's take a look here. And I'll do another sketch of this one for 4. 4 is actually an x cubed graph. That's why I said this works better with a mouse. Let's see. All right. So if I take that, if I rotate this, it is, other than this is just a rough sketch, it's exactly the same. You're still going up and through just like you were here. That is symmetrical about the origin. So that is odd. And literally, you could print this off, rotate the paper. It will look exactly the same. Now I want to make sure to go over how this works algebraically. Even will come out exactly the same. Odd comes out, everything is the opposite. What you do, you change x to negative x. Then you go through the sign changes. If you raise negative x to the third power, well, it's still x times x times x, but let's think about the signs. A negative times a negative for the first 2 powers, that's negative x, or excuse me, positive x squared. Double negative is a positive. But that third one, you don't have to write this out. I'm just showing you what's going on here. Negative times a negative, positive, but then the third one switches it. And then minus negative, that's plus. Everything, this was positive, it changed to negative. That one was minus, it changed. Everything is the opposite. Odd. Now, number 2, same idea. Put negative x in. Go through the sign changes this time. X, negative x to the 4th. Okay, think about it. 4 powers. Negative times a negative, positive. Negative times another negative, back to positive. Still x times x times x times x, x to the 4th. Negative x squared in parentheses. Negative times a negative, positive. So there is no double negative sticking out extra to change 2 to plus 2. It stays minus. Again, remember this right here is x squared. Negative times a negative, positive. So there's no leftover double negative to switch that back. The whole thing is exactly the same. Even. Number 3, same idea. Here's a neither. The first negative x squared switches to positive, so it's the same as the original. But look what happens here. 2 times negative x switches back. the whole thing is not the same. The whole thing is not opposite. X squared plus 1 stayed the same. The 2 in the middle change signs. If you have a mix, it's 9.